Hello students, in the first part of this session, we have solved some examples from practice set 6.1 from the topic trigonometry, class 10th maths part 2. We'll continue the next part of practice set 6.1. Now let us have the first question in this session. Question is, prove that sin square theta divided by cos theta plus cos theta is equal to sec theta. In this question, we have two sides, left hand side and the right hand side. To solve such type of questions, we have to choose any one of the side and we have to go on solving to get the other side. And by doing this, we can show that the left hand side is equal to right hand side. So let us consider the left hand side. So LHS is sin square theta divided by cos theta plus cos theta. Now for this side, we have to make some adjustments so as to have the right hand side. So for this one, if we cross multiply, as we can see, in the second term, cos theta do not have a denominator. So when any algebraic term do not have a denominator, at that time it is 1. So if we cross multiply, we get sin square theta into 1 plus cos theta into cos theta, that's cos square theta, divided by cos theta into 1, that is cos theta. Now we have one trigonometric identity which shows the relation between sin theta and cos theta. That is, the first trigonometric identity is sin square theta plus cos square theta is equal to 1. So instead of sin square theta plus cos square theta, we can write here 1 divided by cos theta. And we know that cos and sec are the reciprocals of each other. That's why 1 divided by cos theta is nothing but the sec theta, and which is nothing but the RHS. So we have started with the LHS and we get the RHS. That's why we get LHS is equal to RHS, that is sin square theta divided by cos theta plus cos theta is equal to sec theta. So that is we wanted to prove. Now let us consider the next problem, in which also we have to prove this one. Cos square theta into bracket 1 plus tan square theta is equal to 1. So again here consider the left hand side. Left hand side is cos square theta into bracket 1 plus tan square theta. So here if we multiply by cos square theta into bracket, we get cos square theta into 1, that's cos square theta, plus we have to multiply tan square theta by cos square theta, that is cos square theta into tan square theta. Now we take the first term as it is, cos square theta plus cos square theta into, instead of tan square theta we can write sin square theta divided by cos square theta, because tan theta is equal to sin theta divided by cos theta. Now here in the numerator and denominator, cos square theta will get cancelled, so as to have cos square theta first term as it is, plus in the second term in the numerator and denominator cos square theta will get cancelled, so as to have only sin square theta. So we get here term sin square theta plus cos square theta, which is 1, because the first trigonometric identity is sin square theta plus cos square theta is equal to 1. So we get here 1, and which is nothing but the RHS. So we have proved here that LHS is equal to RHS, that is cos square theta into bracket 1 plus tan square theta is equal to 1. Now let us have the next question. Here also we have to prove that under root 1 minus sin theta divided by 1 plus sin theta is equal to sec theta minus tan theta. So again consider the LHS. So the left hand side is under root 1 minus sin theta divided by 1 plus sin theta. Now as you can see on the RHS, we have sec theta minus tan theta, that is no square root sign is there. So we have to remove this square root sign on the left hand side. So for that we have to rationalize the denominator. And to rationalize the denominator, we have to multiply the denominator by its conjugate. And we know that 1 plus sin theta, its conjugate is 1 minus sin theta. So we'll take the first term 1 minus sin theta divided by 1 plus sin theta as it is. Now we have to multiply both the numerators and denominators by the conjugate of the denominator. And the conjugate of denominator is 1 minus sin theta. So we have multiplied here both numerator and denominator by 1 minus sin theta. Now if we multiply numerators and denominators respectively, we get under root 1 minus sin theta into 1 minus sin theta, that is 1 minus sin theta bracket square, divided by, in the denominator we have 1 plus sin theta into 1 minus sin theta. Now this is the expansion of a square minus b square. We have the expansion formula for a square minus b square as a plus b into a minus b. By using this expansion formula, we can write here first term square, and the first term is 1, that's why 1 square, minus second term square, and second term is sine theta, that's why sine square theta. The next step we have the square root sign, the numerator as it is 1 minus sine theta bracket square divided by, instead of 1 minus sine square theta we can write cos square theta, because we have the first trigonometric identity sine square theta plus cos square theta is equal to 1, which can be also written as 1 minus sine square theta is equal to cos square theta. That means instead of 1 minus sine square theta we can have cos square theta. Now to the next step, in the numerator 1 minus sine theta bracket square is there, so this square and square root will get cancelled to have 1 minus sine theta in the numerator, and in the denominator we have cos square and the square root sign, so square and square root will get cancelled to get cos theta in the denominator. Now if we separate the numerator, it can be written as 1 divided by cos theta minus sine theta divided by cos theta. Its reciprocal is sec theta minus, by the formula we have sine theta divided by cos theta, that's tan theta. So here we get the RHS, that is sec theta minus tan theta. So we have started with LHS and we get the RHS, that's why LHS is equal to RHS. That means we have proved under root 1 minus sine theta divided by 1 plus sine theta is equal to sec theta minus tan theta. Let us consider the next question. Sec theta minus cos theta into another bracket cot theta plus tan theta is equal to tan theta into sec theta. Again consider the LHS, that is sec theta minus cos theta into bracket cot theta plus tan theta. Now instead of sec theta we can write 1 by cos theta, because these two are reciprocals of each other, minus cos theta as it is in the first bracket. Now in the second bracket, instead of cot theta we can write cos theta divided by sine theta, as we know that cot theta is equal to cos theta divided by sine theta, plus, and instead of tan theta we can write sine theta divided by cos theta. Now if we go on further simplifying, here if we cross multiply we get 1 into 1, that's 1, minus cos theta into cos theta, that's cos square theta, divided by cos theta, into another bracket. Here also we should cross multiply, so cos theta into cos theta, it is cos square theta, plus sin theta into sin theta, that's sin square theta, divided by sin theta into cos theta. So the next step we get 1 minus cos square theta, that is sin square theta by the trigonometric identity, divided by cos theta, into, here also first trigonometric identity is sin square theta plus cos square theta is equal to 1. So instead of that we can write 1 divided by sin theta into cos theta. Now here in the numerator and denominator sin theta and sin theta will get cancelled. So out of sin square theta, 1 sin theta will get cancelled with the sin theta in the denominator, so as to have sin theta in the numerator divided by cos theta as it is, into, in the second term we will have 1 divided by cos theta. So again here sin theta divided by cos theta, that's tan theta, into 1 by cos theta we get sec theta, as these two are reciprocals of each other. So here again we get the right hand side. So we have started with left hand side and we get right hand side, that's why LHS is equal to RHS, that is we wanted to prove sec theta minus cos theta into cot theta plus tan theta is equal to tan theta into sec theta. Now let us consider the next problem. Cot theta plus tan theta is equal to cosec theta into sec theta. Again consider LHS, that is equal to cot theta plus tan theta. So instead of cot theta we can write cos theta by sin theta, plus we have the formula for tan theta, that is sin theta divided by cos theta. So we should cross multiply cos theta into cos theta, that's cos square theta, plus sin theta into sin theta, that is sin square theta, divided by sin theta into cos theta. So by using the trigonometric identity we get the value for this sin square theta plus cos square theta as 1 divided by sin theta into cos theta as it is. Now we can write this as 1 divided by sin theta into 1 divided by cos theta. And we know that 1 divided by sin, that is the reciprocal of sin is cosec theta, and the reciprocal of cos is sec theta. So instead of these two we can write cosec theta into sec theta, that is the RHS. So LHS is equal to RHS, that is we wanted to prove here. Now let us have the next question. 1 divided by sec theta minus tan theta is equal to sec theta plus tan theta. Again consider the LHS is equal to 1 divided by sec theta minus tan theta. Now here also we have to multiply both the numerators and denominators by the conjugate of the denominator. That is, we have to multiply both the numerator and denominator by sec theta plus tan theta to get the right hand side. So here we have multiplied numerator and denominator by sec theta plus tan theta. So now if we multiply the numerators and denominators respectively, we get sec theta plus tan theta into 1. That is sec theta plus tan theta divided by, in the first bracket we would have sec theta minus tan theta into the second bracket sec theta plus tan theta. Now this is the expansion of a square minus b square. So instead of this we can write first term square minus second term square. So to the next step, we'll take the numerator as it is, sec theta plus tan theta divided by, the first term here is sec theta, so its square should be there. It is sec square theta minus the second term is tan theta, that's why we can write here tan square theta, as this is the expansion of a square minus b square. So instead of this we can write here first term square minus second term square. Now to the next step, sec theta plus tan theta in the numerator as it is, and we have the second trigonometric identity, that is 1 plus tan square theta is equal to sec square theta. So here in this trigonometric identity, if we take tan square theta to the right hand side, we get sec square theta minus tan square theta is equal to 1. So here in the denominator, instead of sec square theta minus tan square theta, we can write 1. So the next step we get is sec theta plus tan theta, which is the right hand side of this equation. So we have proved here left hand side is equal to right hand side, and eventually we get the result. It is 1 divided by sec theta minus tan theta is equal to sec theta plus tan theta. Let us have the next problem. Sin raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. So again let us consider the left hand side. It is equal to sin raised to 4 theta minus cos raised to 4 theta. So instead of sin raised to 4 theta we can write it as sin square theta bracket square minus, instead of cos raised to 4 we can write cos square theta bracket square. So this is in the form a square minus b square. So we can use that expansion formula. A square minus b square is equal to a plus b into a minus b. So in the first bracket we should have sin square theta plus cos square theta into the second bracket we would have sin square theta minus cos square theta. Now for this one we have one substitution. Sin square theta plus cos square theta is equal to 1. That is the first trigonometric identity. So instead of this we can write 1 into bracket sin square theta minus cos square theta. So that is equal to sin square theta minus cos square theta, because this bracket into 1 will get the bracket itself. Now again we have one substitution for sin square theta, as sin square theta plus cos square theta is equal to 1, which is the trigonometric identity. If we transfer here cos square theta to the right hand side, we get 1 minus cos square theta, and on the left hand side we would have sin square theta. So this is the substitution for sin square theta. In this equation we have substituted sin square theta by 1 minus cos square theta, and the second term cos square theta as it is. Now here in this equation we get 1 minus cos square theta minus cos square theta. So minus cos square theta minus cos square theta, we will get 1 minus 2 cos square theta, which is nothing but the RHS. So LHS is equal to RHS. Here also we have proved this result. Now the next question is sec theta plus tan theta is equal to cos theta divided by 1 minus sin theta. Again consider here the left hand side, that is sec theta plus tan theta. Instead of sec theta we can write 1 divided by cos theta, as these are reciprocals, plus instead of tan theta we have sin theta divided by cos theta. Now as we can see, for both of these fractions the denominator is same, so only we have to add the numerators, that is 1 plus sin theta divided by cos theta. Now to the next step we have to multiply both the numerators and denominators by the conjugate of 1 plus sin theta, and the conjugate of 1 plus sin theta is 1 minus sin theta. So we have taken this term as it is and we have multiplied both numerator and denominator by 1 minus sin theta. So if we multiply the numerators and denominators respectively, we get 1 plus sin theta into 1 minus sin theta in the numerator divided by cos theta into 1 minus sin theta in the denominator. Now this is in the form a plus b into a minus b. So instead of this we can write first term square minus second term square. So the first term is 1, that's why 1 square, minus second term is sin theta, that's why sin square theta. And the denominator as it is, cos theta into bracket 1 minus sin theta. Now again we have substitution for 1 minus sin square theta as cos square theta, because sin square theta plus cos square theta is equal to 1. It is the trigonometric identity. If we transfer sin theta this time to the right hand side, we get cos square theta is equal to 1 minus sin square theta. So instead of 1 minus sin square theta, we have written here cos square theta divided by cos theta into bracket 1 minus sin theta. So here in the numerator and denominator, cos theta will get cancelled. So in the numerator we have cos square, out of which 1 cos theta will be eliminated. So we have cos theta divided by 1 minus sin theta in the denominator, which is the right hand side. So here also we get the result, left hand side is equal to right hand side. Sec theta plus tan theta is equal to cos theta divided by 1 minus sin theta. Let us have the next question. If tan theta plus 1 by tan theta is equal to 2, then show that tan square theta plus 1 by tan square theta is equal to 2. Now here we have to start with the given. So firstly, the first equation is given, tan theta plus 1 by tan theta is equal to 2. So we'll start with that one. The expression what we have to prove, in that the square is involved. That's why we have to make squares of both of these two sides. So squaring on both the sides, we get tan theta plus 1 by tan theta bracket square is equal to 2 square. Now here we have to use the expansion formula for a plus b bracket square. So the expansion formula is a plus b bracket square is equal to a square plus twice ab plus b square. So by using this formula, we get the first term square, that is tan square theta, plus 2 into first term into second term, that is 2 into tan theta into 1 by tan theta, plus second term square, and the second term square is 1 divided by tan square theta is equal to 2 square is 4. Now here in the second term, tan theta in the numerator and denominator will get cancelled to get the equation tan square theta plus 2 plus 1 by tan square theta is equal to 4. Now if we transfer 2 to the right hand side, we get tan square theta plus 1 by tan square theta is equal to 4 minus 2, because plus 2 going to the right hand side, it will become minus 2. So we get tan square theta plus 1 by tan square theta is equal to 4 minus 2, that's 2. So that is we wanted to prove, it is tan square theta plus 1 by tan square theta is equal to 2. Now the next question is tan a divided by 1 plus tan square a bracket square plus cot a divided by 1 plus cot square a bracket square is equal to sin a into cos a. Here we have to start with LHS. So the left hand side is tan a divided by 1 plus tan square a bracket square plus cot a divided by 1 plus cot square a bracket square. Now for both of these two terms, in the denominators we have 1 plus tan square a, and in the second term we have 1 plus cot square a. So we have the substitution by having the trigonometric identities, that is 1 plus tan square a is equal to sec square a, which is the second trigonometric identity, and 1 plus cot square a is equal to cosec square a, which is the third trigonometric identity. So we have replaced here 1 plus tan square a by sec square a and 1 plus cot square a by cosec square a, and the bracket squares are there. In the next step, we have tan a divided by sec square a bracket square, that is sec raised to 4a, plus cot a divided by cosec raised to 4a. Now in the next step, we have substitution for tan a, that is sin a divided by cos a divided by, instead of sec raised to 4a, we can write 1 divided by cos raised to 4a, plus instead of cot a, we can write cos a divided by sin a divided by, instead of cosec raised to 4a, we can write 1 divided by sin raised to 4a, because cosec and sin are the reciprocals of each other. Now if we take these two terms in the numerator, we would take its reciprocals, that is in the first term the numerator sin a divided by cos a as it is, into, if we take 1 divided by cos raised to 4a in the numerator, its reciprocal should be there, and its reciprocal is cos raised to 4a, plus in the same way cos a divided by sin a as it is, into, if we take 1 divided by sin raised to 4a into numerator, its reciprocal is sine raised to 4a. Now here in the first term, out of cos raised to 4a, 1 cos and the cos a in the denominator will get cancelled to have sine a into cos cube a, plus in the second term also, out of sine raised to 4a, 1 sine will be eliminated by the denominator to have cos a into sine cube a. Now we have got these two terms from which we can take sine a into cos a common. So in bracket we have cos square a plus sine square a. And we know that cos square theta plus sine square theta, which is the trigonometric identity, sine square theta plus cos square theta is equal to 1. So instead of this we can write 1 into sine a into cos a. So sine a into cos a into 1, we get sine a into cos a, which is the right hand side of the given equation. So here also we have proved left hand side is equal to right hand side. The next question is sec raised to 4a into bracket 1 minus sine raised to 4a minus 2 tan square a is equal to 1. So let us consider the left hand side, sec raised to 4a into bracket 1 minus sine raised to 4a minus 2 tan square a. So here instead of sec raised to 4a, we can write 1 divided by cos raised to 4a into 1 minus sine raised to 4a. So this is in the form a square minus b square. We can expand it by using the formula a square minus b square is equal to a plus b into a minus b. That is, in the first bracket we have 1 minus sine square a, and in the second bracket we have 1 plus sine square a, minus 2 into, instead of tan square a we can write sine square a divided by cos square a. So first term 1 by cos raised to 4a as it is, 1 minus sine square a, instead of that we can write cos square a because of this trigonometric identity, and the second bracket 1 plus sine square a as it is, minus 2 into sine square a divided by cos square a. Now here cos square a and out of cos raised to 4a, cos square a will get cancelled. So we have in the denominator cos square a, and in the numerator we have 1 plus sine square a minus 2 into sine square a, that is 2 sine square a divided by cos square a. So for these two terms the denominators are same, so we can just subtract the numerators, that is 1 plus sine square a minus 2 sine square a divided by cos square a. Now this sine square a minus 2 sine square a, we will have 1 minus sine square a divided by cos square a as it is. So again here 1 minus sine square a, instead of that we can write cos square a divided by the denominator cos square a as it is. On both the numerators and denominators cos square a will get cancelled to get the result 1, which is the right hand side of the equation. LHS is equal to RHS. So here also we have proved this. Now let us have the next question. Tan theta divided by sec theta minus 1 is equal to tan theta plus sec theta plus 1 divided by tan theta plus sec theta minus 1. For this problem we cannot solve this by starting the left hand side and getting a right hand side. For this one we have to use the another method. So for that one we have to use this trigonometric identity. So this is the second trigonometric identity, 1 plus tan square theta is equal to sec square theta. So we'll consider firstly that one. If we take 1 to the right hand side, we get tan square theta is equal to sec square theta minus 1. So tan square theta is equal to, now this is in the form a square minus b square. So the expansion formula is a plus b into a minus b. That is, in the first bracket we should have addition of these two terms, and in the second bracket we should have subtraction of these two terms. So in the first bracket we have sec theta plus 1, and in the second one we have sec theta minus 1. Now we can split tan square theta as tan theta into tan theta, that is equal to the right hand side as it is. Now if we take sec theta minus 1 to the left hand side, it will mean the denominator. On the right hand side we will have sec theta plus 1 divided by tan theta. The next step, tan theta divided by sec theta minus 1 as it is, that is equal to sec theta plus 1 divided by tan theta, that is equal to tan theta plus sec theta minus 1 divided by sec theta minus 1 plus tan theta. And this is written by the property which we have studied in the 9th standard, that is by theorem on equal ratios. Suppose two ratios are given to be equal, and if we add the first terms and the second terms of those two equal ratios and the result we get, that will be also equal to each of the ratio. That is, this is the first ratio, this is the second ratio, and in third one we have added the first terms, that is terms in the numerators, that is tan theta plus sec theta plus 1. So that is written in the numerator, and in the denominator we have added the second terms, that is the denominators, is sec theta minus 1 plus tan theta. So this is the second term, and this is the ratio we got by adding these two. So this ratio must be also equal to both of them. That means this is the theorem on equal ratio. So by that we can write this one, tan theta by sec theta minus 1 is equal to sec theta plus 1 divided by tan theta, and that is equal to tan theta plus sec theta minus 1 divided by sec theta minus 1 plus tan theta. So if we rearrange these terms, we get the first term tan theta divided by sec theta minus 1, that is equal to tan theta plus sec theta minus 1 divided by tan theta plus sec theta minus 1. So we have skipped here the second term, as we have proved only first term is equal to the third term. So here tan theta divided by sec theta minus 1 is equal to tan theta plus sec theta minus 1 divided by tan theta plus sec theta minus 1. So this is the left hand side and the right hand side of the given equation that we wanted to prove.